My name is Joseph Cheban. I work for Eon Reality in Irvine, California. I'm a chemical engineer. I worked for 36 years for a major oil and gas company. During the presentation in Houston, we'll get into specifics of my career if people are interested. I retired about 3 years ago and was invited by Eon Reality to join their advisory board. And so I am, for Eon Reality, the oil and gas expert. And today I would like to speak to you about virtual reality for the oil and gas industry. To get started, I would like to make a case for action, and we call this the Oil and Gas Industry Challenge. And many of you are familiar with this. Demographics show that a large number of experienced people are going to be retiring over the next few years, resulting in a very severe knowledge drain in the industry. Well, these experienced workers will be replaced by very talented young people, but they need to be trained in a very quick manner. And while this training is going on, we have to maintain our high safety performance and plant reliability. And I'm going to get into this in the next few slides, but the normal classroom and on-the-job training, in our view, is insufficient to get these new talented workers assimilated into the workforce in a timely manner. Now, how is training done today? Well, we have two different groups of operators that work in the oil and gas industry. We have the field or plant operators, I call them, or the computer or the console operator. And if you look at the top, the plant operator who goes out and maintains and checks on all the equipment, when we train them, we typically train them in a classroom type setting. The computer console operator, on the other hand, works in a control room, typically 1 to 2 kilometers from the main plant, and they work in the facility that you can see on the bottom left that looks more like something out of Star Trek. With the board, with a lot of inputs, data inputs, a lot of alarm systems. And the way we train them is on the bottom right. There are a lot of companies that develop accurate simulators of the plant. And you can see the gentleman on the right in front of the laptop with the instructor over his shoulder explaining about different things. And these are the two types of training that we do, and the training is generally done separately. Now, let me point out that in my experience when I was working, I have a lot of experience working on projects and working in plant type of settings. I work with many, many, many talented field and console operators. And the field operators, and I taught a lot of class training for about 20 years. I was an instructor, a subject matter expert. And my experience is while the plant operators are very talented and very smart, they generally do not like sitting in the classroom absorbing information. The general plant operator is very mechanically inclined and a person who likes to learn by doing. So if you're in a classroom type setting, they get bored very quickly and they don't absorb information very well, and it's a very inefficient way of doing it. On the other hand, the computer console operator, when they go through a console simulator, that is very, very closely aligned with what they normally do, and that generally is a very, very good way of training them. Okay, so when we got started on developing this operator training system, we came up with a training philosophy that I want to share with you. Because we have to train people in such a short period of time, we wanted to develop what we call a flight simulator for process operators. So in commercial and military aviation, because planes are so reliable, it's very, very difficult for a pilot to see all the different problems they can have because the planes basically fly themselves. So they built flight simulators so that they can simulate a stuck rudder, a fire in an engine, all types of scenarios so that the pilots can practice them. So if it does happen, on that rare occasion, they know how to react correctly. Well, we want to use that same training philosophy for our process operators. In the world of oil and gas, and I'll even extend that to power generation, to nuclear, any type of process where you have people that interface with sophisticated equipment. Over the years, we've made those facilities very, very safe and very reliable. It's rare that you're going to have a major upset in a production facility. The double-edged sword on that is that the operators lose a lot of experience because they don't see upsets that frequently. So our argument is that we could use 3D in order to simulate a plant environment and then develop scenarios such that we can train the operators to identify problems quickly and to solve them. So again, our training philosophy is virtual 3D is arguably the best vehicle to enhance existing training programs to provide the required hands-on experience in a very short period of time. So we can make the 3D environment so realistic that it can mimic the real world field environment. We could do that visually by making high-quality photorealistic graphics, and then we can add to the 3D environment what we call 4D effects, such as directional sound and other sensory inputs, so that the person that's in the simulator actually feels that they're in a real plant environment. Another training philosophy point that I want to make is, on the previous slide, we talked about the plant operator and the console operator and the different ways that we train them today and how they train separately. It's extremely important that in order to have an effective training environment, that the natural work teams must train together. And why is that? Because when everything is calm, people have no problem communicating over their radios and understanding instructions and carrying out instructions. But most of you probably know from a plant environment, when upsets do happen, things get to be very chaotic very quickly. And the natural work teams need to learn how to communicate effectively, so during that period of time of stress, they can actually communicate correct information and carry out instructions correctly. So by training together, they can actually work on those communication issues, and they can help them efficiently resolve problems before they can escalate. As I mentioned, we can develop any kind of training scenario that you can imagine. We typically work with our clients and ask them to come up with the top 10 or top 20 type of upsets that really keep them awake at night, basically. And we can develop training scenarios around those. And then we can have these scenarios displayed in a 3D visualization device and have the operators work and train in those devices. And after they go through it once, typically the first time or first several times, they don't do it right, and we have to do it over and over again. All we have to do is hit the reset button. And we can keep doing this until the trainees develop an understanding of how to best respond to certain problems. Now, I talked about the field operator and the console operator. That's a one-on-one kind of training. But typically, the console operator is responsible for 3, 4, maybe 5 field people who are actually walking around in different geographical areas of the plant. Somebody may be in charge of the feed system. Someone may be in charge of the reaction system. There may be a product fractionation section. There may be offsites and utilities. And one console operator may be responsible for those 3 or 4 different areas. Well, Eon has a software called Eon Coliseum that can link multiple display devices together. So we can have one display device for the feed person, one for the reactor person, one for the product fractionation, one for the offsites and utilities. And we can have the same 3D model of the plant being displayed on all those display devices. And each of those field people can navigate independently through their section of the plant and can interact independent of the other people through their section of the plant. And what we could do now is we can have total team training, as we call it. This is not, there's no one on the planet that is doing multiple training. And why is this important? Again, in an upset situation, when things get chaotic, sometimes those upsets span the entire length on the entire area of the plant. And several field people need to be working with the console operator in order to identify and quickly arrest those problems so they don't escalate. By training together, the total team knows how to communicate and coordinate their activities efficiently so they can identify and solve the problems very, very, very fast. And as I mentioned, if there's anything you need to take away from this presentation, I would appreciate if you guys can incorporate the fact that we're trying to build a simulator just like is done to train military and commercial pilots. When people understand that we're developing a simulator just like what's done for pilots, it clicks. They really understand what we're trying to do. Okay, so that's our training philosophy. So we went about and we developed a training simulator. We developed a 3D virtual reality simulator for training operators, and we use the user, because it's so sophisticated, because the graphics are so realistic, because the 4D effects are incorporated, the users have the same experience as being on site. Of course, we use the state-of-the-art technology in 3D visualization, and the iCube, as we call it, basically it's a small room where each of the walls is a display screen. It's an immersive environment where you go in, and as you navigate through the 3D model, you can actually walk around it, walk around equipment as if it was really there. So you see the picture on the top. The gentleman has a handheld device, Xbox controller, and he's actually looking at a control valve station in a gas processing plant. And you can actually navigate to the other side of it. You can actually look underneath it. You can look on top of it. You can actually open and close valves using that Xbox controller. During the presentation in Houston that I'll make in early November, I actually have a video of this gentleman navigating around the 3D model, and you'll be able to see how he actually manipulates things in 3D. You can see two pictures. I have the same picture of the console operator that I showed on the other slide on the bottom with a line between the two, and it actually shows a connection between the console simulator and the 3D model. So that's part of our patent development, is that we do everything by tags, temperature, pressure, flow rate tags, and on the bottom the console simulator is actually calculating the values of all the different tags roughly 7 times a second and streaming that data into the display device, and all the tag information is updated continuously. So for example, if the console operator on the bottom actually changes actually blocks off a valve on the bottom of a knockout drum, for example, the person in the top, as they go over to that knockout drum, would actually see the level in the knockout pot actually rising. So it's live, it's interactive, and the data is streaming back and forth. Also, if the person on the top closes a valve, the console operator will see the effect on their computer screen. So we've connected the two, and the information flows between the two, and then we can train both people in different scenarios. Okay, and again, they could practice together. We could do very routine operations like swapping pumps or taking samples, or just even taking just general readings, or we could do emergency response for low probability, high consequence events. These are the events that take place maybe every 5, 10, 20 years. It could be a gas release, a fire, it could be even an explosion. So we could simulate all those and see how the operators respond to that. In the case of a major upset, like where you do have a fire and explosion, it really would be good to test the field operator to see where they have all the emergency block valves so they can isolate sections of the plant. We could do things like that. But also we could do any type of plant procedure or abnormal event so that both the console person and the field person can practice together, again, to identify quickly and to put the unit in a safe condition. I mentioned on the previous slide Eon Coliseum, where we can link multiple display devices together and actually do total team training. And this simulator, we have applied patents, and the patents are pending right now, and I will explain more of that when I make my presentation in Houston. Okay, so we had, after we developed the simulator, we did a proof of concept where we did a simple compressor simulation. And you can see on the bottom left picture, this is the 3D model of that compressor skid. And if you look on the picture on the right, that's what the computer console would look like. And in the middle picture, you see my colleague, he's actually navigating through the display device, and he's actually looking at the bottom of that control valve station I mentioned before. So it's an interactive compressor skid where the field operator can open and close multiple valves, push buttons, take samples, and you have on the right side the console simulator where the console operator can manipulate valves under their control. We have 3D interactive objects. As a trainee goes through the 3D model, if they forget some fundamentals like how does a compressor work, we actually have little icons that you can press and videos come up that give you tutorials. We have fully integrated sound effects. We have what we call, well, we have the iCube console connection because that's the operator training system that I described. And we have collision detection, which means that you just can't walk through a virtual object that stops you from doing that. Again, with Eon Coliseum, we can connect multiple iCubes together. And overlaid on top of this is a learning management system that keeps track of the trainees' progress so that we can see them improving over time as they go through multiple training scenarios. So we did that proof of concept, and we knew that it worked, and then we applied for patents. And then we wanted to scale it to see if there were any limitations on Eon software as we got to a larger and larger facility. So you can see the pictures here. We actually have an oil and gas processing facility that is roughly 1 kilometer by a half a kilometer footprint. Over 300 pieces of equipment are actually modeled and displayed. We have multiple field operated devices that are interactive. Took about 1.5 years for us to develop this because we wanted to see if there were limitations. So you can see on the left side the helicopter view of the facility, and you can see how sophisticated it is. In the middle picture is a close-up of a valve station, so you can see how sophisticated the graphics are. And we connected it to a console simulator of that facility, and you can see the schematic on the right. It's fully interactive. Again, the data streams between the two, so if the person, the field operator makes a change, the console operator can see it, and vice versa. And we have multiple training scenarios that were part of the computer simulator. We have that incorporated into the 3D model. So again, the console operator and the field operator can train together on various training scenarios. So we scaled it up. We had to modify Eon software so that we could display these devices. It's a huge model. It's roughly 150 million polygons, but you can navigate through that seamlessly. During my Houston presentation, I actually have a video clip of us navigating through the 3D model on the left so you can see that there's no jerkiness, that the hardware can keep up with the sophisticated software as we move through the model. It's very, very cool. Okay, so now, once you have this training scenario, again, when I was working for the large oil and gas company, we never like to purchase anything or build anything for just one use. We like to have it for multiple use. So once you have a 3D display device connected to the computer console, you can actually use it for a wide variety of purposes. And let me explain how you can use the 3D setup throughout the value chain in oil and gas. Well, initially, when you look for oil and gas, you go through an exploration event. The picture on the bottom shows a reservoir engineer looking at a underground formation that's seismic data that has been conditioned to be able to be displayed in a 3D visualization device. So that you can teach your reservoir engineers on how best to examine rock formations to look at where the best opportunities are to find oil and gas, or once you find the oil and gas, you can look at the most optimal way of getting at those. So you can use that for exploration. Once you find the oil and gas, you have to get it to the surface and process it. So you have to build a facility on the surface, and you can use this 3D display device to display an early rendering of what the surface facilities will look like. And you can do what we call design reviews. This is very, very cool because, as many of you know, early on in a project development, it's easy to make changes and it's very cheap or cost-effective to make changes. As you go on in the project cycle, it's more and more difficult and very expensive to make changes. So once you have an idea what your surface facilities are going to look like, you can have an early design and you can actually go through the design assessments, you can go through ergonomic assessments, you could do safety reviews, and build in those changes early before we even break ground for the facility. And once the facility is built, you can still use the 3D model to do other things. You can, a big thing is turnaround planning. Many of these facilities have to come down every 3, 4, 5 years for a major maintenance turnaround that lasts anywhere from 30 to 60 days. Each day that that plant is down is multi-millions of dollars of lost revenue to the facility operator. These turnarounds are so sophisticated and complex that you could use this 3D model to actually plan out your turnaround well in advance so that you can actually meet that turnaround deadline of maybe 40, 50, 60 days, or if you're really good, you can actually cut down a couple of days and save many millions of dollars. The other thing that's really good, and keep in mind, is as you start planning your turnaround, a lot of times you bring in other contractors in order to help you with the turnaround. You can actually bring them into the 3D visualization device and actually have them help you plan out the turnaround so you could do it efficiently and avoid surprises. So in addition to turnaround planning, you could do safety training for your operators on what we call dangerous tasks or what-if scenarios, and you could do your safety training, and you could do even general training for new hires. So basically, what can Eon Reality provide to our clients? Well, we have generic training solutions that include these high-quality 3D graphics and training scenarios. So what do I mean by that? Well, I mentioned on this previous slide that it took about 1.5 years to develop a very sophisticated model of a gas processing plant. Now, companies don't want to wait 1.5 years before they start training, so we have generic training solutions for distillation, compression, for liquid pumping, for reactions that we could provide to the client, and they can get training, get started in training in as little as 3 months after signing the contract. But there are certain clients that would like very specific training solutions, or custom training solutions for a section of the plant or for a particular plant, and that could be provided if necessary. So in addition to the graphics, we can also provide the display devices. We have an iBench mobile. You can see the picture on the bottom. One of our workers, Brendan Riley, is actually showing how you can use the 3D display device, or iBench, and we're going to have that at our booth during the presentation. We have a one-wall 3D interactive device, which is very much like IMAX, called an eye catcher. And we have the iCube that you saw pictures of. It's up to 6-wall interactive and immersive 3D environment where the trainee can view a 3D object from all directions. So we can provide those display devices as well. And again, we have that collaborative software where we can link multiple display devices together. So in summary, what we could do is we could provide the whole operator training system, the 3D models, the display devices, the interactivity, the connectivity between the 3D device and the console simulator, and we can link multiple display devices together so we can do total team training. So that's pretty much the presentation, and I'm looking forward to seeing many of you in the Houston conference, and hope that you come by our booth and we can have one-on-one discussions. But just to summarize, Eon Reality has developed an operator training system that's very analogous to what is done for commercial and military pilot simulators, where we have 3D graphics of a production facility and link that to a simulator of the computer console, and now we can train the field and the console operator together, but we can also train the total team together on rare emergency response scenarios, so that when they do happen in the real world, your operators will be better prepared to identify and to deal with those. So thank you very much, and I'm looking forward to seeing you in Houston.